Welcome back, generals, to another Let's Fix Generals 0 Hour to make the best game ever. Okay, so last session we have reviewed some stuff, and the session before that we have drafted the structures. Okay, I guess they more or less go into the direction that we need. How about we create some new files here? Let's create a MachO reader. MachO reader dot h. Yeah, and then we create a MachO reader dot cpp. Yeah. Okay, and then we probably need a let's do MachO reader types dot h and MachO reader MachO. Actually, let's call this CPP types. How about that? CPP types. Yeah. Oops. .cpp. Okay, then we go to our CMake txt and we put in here the CPP types. CPP types dot h CPP, and then the MachO reader CPP and header. Okay, good. Let's compile that. Okay, then once that is done, we will open the CPP types. Yeah, so we put a pragma once in here, and we do the same in here, and then we copy these guys here, these guys, we copy them into the CPP types. There we go. Good. Okay, and then we open the here we do include CPP types. I don't know if we actually need this file, but I have it here for now. It's fine. Ta-da, ta-da. Okay. And then the MachO reader, we have this. We do here include MachO reader.h. Okay, then let's just create a submit for that. Let's do include. Nothing so far. Okay. So we take these two, this, put this here, and we take this CPP types. We take this guy. We say move. Move simple types to CPP types .h. Okay. Then next we create a class MachO reader. Yeah, MachO reader, and basically here we will have a function void or bool or void, I don't know, bool read MachO reader. So open fire, I don't know, read fire. What should we call it? Open file, read file, load const or std string view. Let's do here include string view. Yeah, string view path. Oh, sorry. And it should be a public. And we probably also, sorry, we want to include the CPP types. Oh my gosh. Oh man, what is happening? Oh, that's bad. Okay. Those hiccups, man. Brutal. Okay. So, MachO reader. We can probably use user reference. Let's open another solution. Visual Studio 2022. Oh, I'm suffering right now. So we are looking at MachO parser here. Oh. Yeah. So we're looking at this here. Load. And we probably need to make some includes MachO parser. So we're looking at these two. There we go. Let me put here, let's say file path. And oh, this one takes a string. Oh, that's stupid. Well, then we also pass a string here. Oh boy, that's not a string. I have really hard time here. Okay. And binary, fat binary. Leave MachO fat binary. Leave MachO fat binary unique pointer std unique ptr. There we go. Oh my god. Binary if not binary return false. Okay, and then so the parsing, it does parse symbols. Okay, we also need section segments though. Okay, so in our code, so we have CPP types. We probably need all these guys here. I expect here that we will have namespaces. Yeah. Namespaces. Yeah. Enums. Variables. Classes. Functions. Headers. And let's call it header files. And source files. There we go. And then we probably also need the lookups. So we take this here and we do a name to name space index. Yeah. And we do the same for enum index, variable index, class index, function index, header file index, and source file index. And maybe we also need a demangled to functions index. Yeah. Okay, so this could be what we start with. Yeah. Okay. Okay, so section segments. I don't think we need. We already. I don't think we need to create any sections, like elements. We have the sections here. Well, maybe a lookup. Let me see. Does a MachO? Okay. Well, MachO binary. Okay. Oh, okay. Wait. Before we jump into that, there's another consideration we need to make first. Here. So we have a fat binary, but inside the fat binary we have other binaries. Here. Header CPU type. Header. What is this? MachO header CPU type. Okay. How about we do the following here? Leave MachO header CPU type. Yeah, let's call it CPU type. CPU type. Well, sorry. Okay, it looks like we would, hold on. Header.hpp. Leave MachO header.hpp. Leave. Okay. So if I see this correctly, what we should do here is leave MachO header.hpp or the header.h or hpp. Okay, and then we take this guy and we put it here in CPU type. And then basically, so in the main function, we will basically include MachO reader, and then here we would say MachO reader MachO reader. Actually, the reader is good enough. Well, actually, MachO reader, and then we do MachO reader dot load, and then we give it. Let's just put it ZH. I just hard coded now to make it configurable. So we have ZH, and then we put in the leave, and we put the x86, right? There we go. There we go. And then we put here if not load, then turn 1, right? There we go. Okay. Okay, and then here we basically say here binary if we do if binary. Let's see. We have here take take CPU. Oh yeah, and that gives us a, okay, so we take CPU type, and then that will give us this here. So this is fat binary. Yeah, here we have fat binary, and then we have, let's remove this, keep it simple, fat binary, and then we take this guy, and we take this, and this one is a binary take CPU type, if not binary, if, actually let's do it, if fat binary equals null pointer, then this, if binary equals null pointer, then return false, and then otherwise we do a parse, or to parse, if not parse, if not parse, binary, what is this? Binary.hpp. MachO binary. Hold on, I want to see what is inside this header here. MachO.hpp. Can we open it here? Oof. Yeah, we don't need to config. Leave config.h. What is in here? Let's see this real quick. Okay, I would say we do the following. We put this here, leave config.h, and then we include header and binary, binary.hpp, binary. There we go. All right. If not parse, and then we pass a binary here. I think this one doesn't have to be this. Actually, we can forward declare. How about that? There. Let's put a namespace leave MachO header. CPU type, is it default? It's in 32. Class. No, this needs to be fresh. Okay, let's do, we can remove binary. Then, but we can put MachO binary. Hey, hold on. Binary. Class. We can forward declare this class binary. There we go. Okay. And then here we have private bool parse. Yeah. And then here we simply put the leave MachO here and put a binary, and this is reference, make it const. Does it need to be const or not? Should be const, right? Because we are only reading from it, we're not writing to it, right? So I think we have a const binary. There we go. We make another here, private. And then we have MachO reader. If not parse binary. There we go. And then return false. return false, otherwise return true. We could also just return pass, but I think this is fine enough. Okay. Anything else? No, I think that's starter code. And then next step. So basically, we can actually already debug it to see if we get here and everything is good. Let's put this as startup project. We go to properties, we go to debugging, and working directory. We set this to code this and slash dot data. There we go. And no commands, just apply. By the way, we can put this on all configurations. There we go. Put it here. Done. Okay. Apply. Okay. All right. And let's compile. So it should now go in here. And do we have the ZH file in there? If not, we need to put it. We don't. Then we go to MachO analyzer data and we copy the ZH file from here. Yeah, ZH. We just put it in here. Data ZH. There we go. Okay. Then, yeah, let's see if we get in here. We get the correct binary. Then, okay, there is a problem. Okay, return true. There we go. Okay, start, run. So CPU type is x86. Load commands are corrupted. Okay, so this has loaded two binaries. One is x86 and the other one is something else. Interestingly, this one is unrecognized. Yeah, strange. I wonder if there's an error in leave if it doesn't recognize one of the binaries, the first one. Maybe there's something wrong with leave. Yeah. Maybe. Okay, so fat binary, that's loaded. Okay, and now we do this, and this one is working. x86 works, and then it can pass it here, and it's returned true. Okay, so far it works. Well, it wasn't exactly groundbreaking. Good. Good. Take the underlying binary. Take. It's kind of interesting that we can just take it out, right? Maybe take. That's okay. Good. Okay, so far so good. Then the next step is that what do we need to do? We need oh man. Okay. So in the binary there will be now these sections and segments. Okay. Let me see. Okay, I think we will start with looking at symbols. Okay. So we start with this here. Yeah. This kind of thing. Okay, so we have MachO. Let's go in here. Pass. Okay. So symbol to binary symbols. Yeah. Okay, so I think we need to do multiple passes. Let's see what we want to fetch first. I think we first need to this one, yeah. Okay. We probably first want to get hands on these guys here. This one, right? Let me see. I wonder what is the bodily function of hiccups? What does a hiccup fix? Like what is the problem that the hiccup tries to fix in the body? To me, it sounds like a hiccup is just like a spastic, right? It's just a spastic. Like people who have tics, right? When they uncontrollably have to move their limbs or have to say words, right? It's just a spastic. A hic is a spastic, no? I don't know. To me, it doesn't seem like it would fix anything. It's just the body is being retarded. That's all it is, I think. Yeah. Ah, I just realized that this one here. This one seems to be like an overarching symbol here. Right? seems to be like so. It starts with this. Then there's this path. Yeah. Yeah. Okay. And then this object file we probably don't care about. This is a compilant. Yeah. Okay, so we care about this, so we know that this. So let's search for this string here. Full word match case. Well, that didn't work. I wanted to just. Okay, let's do it differently. Find this and then /n. Let's try that. There we go. Aha. Okay, that seems more like it. So there are 826 hits. Does it mean there are 826 files? Does that make sense? If we look at Thyme, Thyme source, at all the files in here, how much files do we have? 1,200. Oh, that's a lot more. So we look at these guys. Oh, this is slow. This is slow. MacDic. Yeah. Start S. Source cache. Proc name. Proc name. Get PC thunk bx. Hidden start. Hidden. Hidden GCC compiled. Okay. Okay, this looks like here the section where it defines like the the the, the functions that are inside this object and the type infos. And then here's a new compile unit starting, compilant. Right. Okay, so this new compilant. Okay, so let's try to map this. So this all this from, so here I think is the start of this portion. GCC2 compiled. This all belongs together, and then here it ends, and here the next one starts. Yeah. Or DIK map. DIK map. What does that stand for? DIK map. Translate to DIK. Translate key code to DIK. Yeah. Okay, so we need to make sense of this stuff. So let's open this guy. I think it's zh.json. This one. Let's go up the list. No. Let's search for. Let's search for this one here. There we go. Hundreds. So this raw type 100, let me see, where's this used? It's here. It's also here. Raw type 100. Okay, what is this symbol here without the name? It's before this one here. Let me see on this here. It's this one here. Problem is, it would be nice if we the thing is when we roll the parsing of this our own, then there's always a chance that we don't do it quite right, that we miss some data, we miss some logic or make some stupid mistakes. Yeah, I mean, like, so for example, I don't know what this thing here is. It doesn't have a name, it just has a value. But what does it say? It's like a large value here. What does this value mean? Is this maybe like an ID, function ID? Function index. Don't think it's an index. This one is pretty high here. So this is the size of the function. What does this symbol mean? So this one tells us what about this one here? Oh, this program is slow. So there are two. Let's open this file in Visual Studio Code. Notepad++ is falling apart here on this big file, unfortunately. Which one is it? Object dump. Disassemble. No, what is it? Object dump. I don't see it. Which file did we look at? Object dump all headers. Ah, here, up here. Okay. Okay, that's retarded. Good. So I want to look at this guy. So there's this here, and then it's again here. What does that mean then? Shake intensities. Okay, I think we still need to research more about what these things mean. So right now, I don't know what this is. There's this here, shake intensities. Okay, so we understand this one. This is the size of this function. These are the the these are the instructions of the function here, these addresses, and this is the begin of the function, this is the last instruction, this is the first instruction, and this is the file that refers to this instruction. So basically it would be basically the symbol at this address refers to something that lives in the header or so. That's my understanding of this. Right? But I think we don't care, because we only, well, we use it for includes. But yeah, we will use this for building includes. But the overarching CPP we get from the top of the end. Yeah, okay. The question is, what is this thing here? Is this identifier used anywhere else? Oh, yes. Look at that. But this is not an address, or is it? Well, it must be. Must be an address. Okay, so it refers to the first code address in this file, I guess. Okay, so if we so if we look for raw type 100, then we will get a very slow file again, of course. Okay. Suffice to say, I don't understand how this works. Shit. My gosh. So yesterday, what did he say? He said, I suggest you download source for Apple GCC that was used to build. Maybe source for GDP. GCC. Well, that would be quite a dick. GCC compiled. GCC2 compiled. Well, I mean, this gives us a hint what it was compiled with. GCC compiled symbols. Compile. Let me ask ChatGPT. These are quite. Are there any resources about GCC2 compiled symbols? SymTab. Sim found in binaries produced by GCC. The symbol is used to indicate this binary was compiled with units. The SymTab refers to the symbol table in the which contains information. For more detailed information on these topics, you can refer into the internal workings of GCC. GCC internal documentation. ELF specification. Sections like SymTab. ELF specification. ELF specification. Does the MachO symbol table also fall under the ELF specification? No. Its structure and organization use different from ELF. Use concepts such as load command segment sections is managed differently. Okay. Okay, but we read this one here, and it's not. This doesn't help us. Maybe there's some other documentation. Let's search for MachO symbol table. Let's see what Wikipedia has to say. Load commands, one or more segments. Relocation format, yeah. I'm looking for some user 2-level namespace that encodes each symbol into an object symbol name pair that is then linearly searched for. Link it. I think that's the name of it, isn't it? Link it. The order the symbols go in the symbol section should never be altered, as each symbol is numbered from 0 up. Each symbol is numbered. The symbol table information command uses the symbol numbers for the order to load the undefined symbols into the stubs and pointer sections. Altering the order would cause the wrong methods to be called during machine code execution. Okay, so the order matters, and this matches my observation, yeah. But, so what does it mean here? The numbers, symbol numbers. So these are symbol numbers, but they are addresses, right? This is an address, dynamic audio event. Dynamic audio events, yeah. So the dynamic linker is reading this. So the dynamic linker knows how to interpret it. Load command. Number, undefined symbol index. Right, so. Okay, let me ask ChatGPT about this. What libraries can read link edit symbol tables? libMachO. Apple's open source CC tools includes libMachO, which provides utility for parsing MachO files. It allows access to segments like linked edit and can extract symbol information. MachO view, MachO. MachO view. libobject. Can parse and analyze MachO files. Link edit. Okay, let me take a look at libMachO. libMachO. This is proprietary. libMachO. libMachO. What is this? MachO view. MachO view. MachO view. Yeah. MachO. Oof. MachO layout. What is this? Link edit. What does this do? really strange code. What does this guy do? Source. What about MachO? Detected. Well, I would like to see what this one gives. This one. Let's see. Assembly Armada MISC. Oof. Okay. Why is there a lib crypto inside? Weird. Okay, what is this do? Open. Commands. Segments. Let's make it larger. Sim tab. X. Okay, I don't know how this is useful. Symbol table. What? What is that? Power PC. Jesus. Ah, it's a nice overview. Okay. Okay. The hell is that? Heuristic scan. Okay, well, I think we need to study a bit more. Like, there's still some unknowns. Like, but so far, all the tools we looked at, they only ever list all the symbols. Right? I've seen no tool yet what actually interprets the symbols. There's the most fancy stuff about listing this, but not so much interpretation. This is what we are missing, and there's no. I haven't seen anything that interprets it in a high level, right? So that would actually be interesting. But ChatGPT said that this would be that the no, I think Wikipedia was it. Wikipedia said that this is read by the dynamic linker. So Apple dynamic linker source code. Is that a thing? Dynamic linker open source. DYLD. Isn't that the linker? Let's ask chat. is dylde the dynamic linker? Well, what is dl? No, dydl ld. Dynamic link editor. Dynamic linker. Okay. So according to Wikipedia, the dynamic linker will read the symbol table. So that means this code here should contain something that understands list symbol table. Locals count, globals count. Move. List symbol table. Symbol name is weak. Code. Man, this stuff is super complicated. Okay, I think I will take a break now. Yeah, I wish you a great day or night. Until next time, goodbye. Sorry for the sudden break, but I actually wanted to take a break 50 minutes ago already. Yeah. All right.